Welcome to the Industrial Internet of Things panel, which is moderated by Emil, and we have, Bernie McPhillips from Telefónica, Robert Hayes from Microsoft, Jonathan Wiggin from NWave, Sean Weir from Arqiva, and as I mentioned, moderated by Emil Berthelsen.
Yep.
I got that right?
That's fine.
For Machina research. Over to you, Emil.
And we have a last-minute invite, which is Paul Green as well.
Sorry. Paul Green from Iotic Labs. There you go.
Thank you very much, Simon. Just really to set the scene here, we're talking about industrial IoT, and so many people ask the question, what's industrial IoT about, and what's the definition of it? To be really honest, there is no strict definition at present on industrial IoT. There are a number of consortiums that talk about industrial IoT. Probably the best way to look at this is it's about IoT as related to enterprises. It's IoT as related to integrating with the workflows of enterprise. It's got to do with companies which have huge legacy systems that have to be integrated with. And it's really more about business critical solutions. I think we had some really excellent presentations and comments about drones, and you can see how that fits in with an industrial IoT concept of they become business critical for the enterprises like the oil and gas industry. I think one of the things that we really are seeing right now is that IoT is changing the game from traditional machine-to-machine and IT, because industrial IoT or industrial IT used to be fairly significant, big, heavy projects, fairly highly intensive system integration projects. And now with IoT, we're talking about some really fast, agile, new development, new applications coming on board. So there's a lot of change going on for enterprises. And really with that, we're seeing a change of mindset. And it's probably with that change of mindset, I'm going to turn to the panel now, a really excellent panel, because we've got almost the full value chain of IoT here, from connectivity providers to application providers to data management companies. Paul will get into that a bit further. But I think what I'd like to do is ask each of the panelists to briefly introduce themselves and really just introduce how does their company address industrial IoT. Sean, if I start with yourself.
Hi, everyone. Sean Weir. Is that working? Okay. Yeah, Sean Weir. I'm the Business Development Director for Arqiva's machine-to-machine, smart systems, smart metering systems, and Internet of Things business. Arqiva is a business perhaps you haven't heard a lot about. We are a communications infrastructure and media services business operating across the telecoms, media, and utilities industries. We're a trusted provider, basically some of the critical national infrastructure that runs the broadcasting systems, the radio systems, and the telecommunication systems of the UK. We are responsible for building a couple of the largest M2M networks in the UK right now. We are deploying the smart metering network in the north of England and Scotland. That's connecting about 99.5% of all homes. We are also building a water smart metering network across all of London and the Thames Valley. Recently, we got involved in the Internet of Things quite aggressively. We have done a piece of business with Sigfox and are now deploying an Internet of Things network across the whole of the UK. It's live currently in the top 10 cities. So basically, if you want to connect to our network in Edinburgh and Glasgow right now, you can. It's live, it's available. If you're from Manchester, Liverpool, Leeds, Sheffield, Birmingham, Bristol, Leicester, London, you can also connect. Okay, so we're operating across that. We do believe the Internet of Things is real. We're kind of putting our investment in there to try and unlock the promise of the Internet of Things by enabling low-power wide area network connectivity to become a reality in the UK. We do believe that somebody has to take a leap of faith here and put networks out there that companies are going to use. Device manufacturers are going to build technologies and devices to connect to these networks and start to enable cities to become smart cities and businesses to transform themselves. We've got a couple of interests in the internet, industrial Internet of Things. I mean, one concern I have is the pace of change and the speed at which organizations and industry is going to adopt the Internet of Things as a digital transformation technology that's enabling them to sort out their operations, customer service, and product development. We're also concerned about the inability of cities to transform themselves into smart cities. We find there's a lot of talk about the Internet of Things in the cities, but basically the technology still sits in the lab, and it hasn't emerged out of the lab into industrial scale at a scale that cities can start to embrace. And we're concerned that cities don't understand how to actually embrace Internet of Things technologies to transform their cities. So there's a couple of interests there that we've got, one around pace of change and the ability of companies to transform, and the one around cities. But basically, Arqiva as a business, we're looking to unlock the promise. That's kind of what we're all about at the moment. Cheers.
Robert?
Hi, I'm Bob Hayes from Microsoft, probably a company you might have heard of. Microsoft's been in what we now call the Internet of Things business for a long time. In fact, many of the historical instances in the industry that we now see as the Internet of Things run on Windows embedded. And that is sort of where I want to start from, because I want to put a little bit of context in when we talk about the Internet of Things in an industrial context. The first is, if you have to think about why embedded systems were put in place and the mindset around how they were. The average deployment of a Windows embedded system is about 15 to 20 years. So if you look at your average sewage works, looking in this room, I can see probably 5 or 6 different devices which are connected in some shape or form to networks in this building. They're all basically industrial Internet of Things. But if you think in the industrial, and I use the sewage works one because I think it's one everyone can relate to, the control unit for a sewage works would be put in with the mindset of minimum maintenance. So the idea was, it was put in, it would be connected to power, it would have a low maintenance operating system that would enable it to take control metrics and command and control from somewhere and do something to a valve or a system. And that was the design. The whole thing was designed in a way that it never needed upgrading. It hopefully didn't need maintenance. And if everything worked well, in 15 to 20 years, you'd come and you'd replace that with something that looked pretty much the same. The problem is that mindset of nothing can connect to it has been proven to be significantly wrong. Because actually now the industrial Internet of Things is connected. If you look at hospitals, hospitals have got oscilloscopes, they've got drug mixing units, which over a period of time someone has said, hey, wouldn't it be good if we could actually control this from here? Or we could get details about what's actually happening over here from here. And so they've talked to their IT department and said, can you patch that somehow into our network? And they're going, yeah, okay. And again, without any great thinking about the upgrading, the security and vulnerabilities, because security and vulnerabilities just weren't on the radar, because the perception was these were things that nobody would ever be able to get at. And actually, there are significant evidence to the contrary. So I don't want to delve too deeply into security because I'm speaking next and I will do about that. But what I think we need to be thinking about in this context is, so how do you change this? Because this isn't just a simple answer of saying, okay, so we can go out and patch all of this stuff. Because actually, the controller on the wall here probably wasn't built with a patching interface in mind. In Microsoft, we have control panels on the side of a lot of our meeting rooms. In Seattle, our Microsoft headquarters, we found malware on the systems that lowered the screen down in some of our meeting rooms. To the best of our knowledge, that had never been connected to anything. So where did it come from? How did it get there and what was it doing? We never really actually found the answer because, again, our mindset had been like everybody else's, that this was something that wasn't actually ever going to be connected. So we have a historical problem of, even if we start now to realize what level of protection that we need to build into these systems, actually, where are they? What's the configuration control? And how do we do that? Moving forward, We are looking like every other platform provider. We now have Windows Azure as our cloud solution, and we have a Windows Azure Internet of Things platform for developers and others. So we see this as the future, but I just wanted to sort of start by looking backwards to say, but my goodness, we have a legacy problem.
Thanks, Bob. Bernie?
Thanks, Emil. Thanks, Bob. My name's Bernie McPhillips. I'm head of the Authorised Distributor channel at Telefónica M2M. A job title that someone created for me before they realised it doesn't fit on a job card, on a business card, which is good of them. In terms of IoT, as a mobile network operator, Telefónica play very horizontally across the market. There's a whole value stack of delivering an end-to-end solution to a customer, be that devices, connectivity, application, system integration, etc. And many of the analysts say that the telcos kind of playing about 10 to 25% of that value stack at the moment. For that reason, I and our organisation firmly believe that power is in the partnership. No one organisation is going to conquer each vertical within the IoT market space. So for that reason, we work with quite a number of partners. We have an aggregator channel, smart connectivity providers. You may have heard of the likes of Wireless Logic, Arqiva, Stream, Wireless. And these are organisations that typically take connectivity from multiple network operators and aggregate it onto solution providers. They can provide multi-network operations. They each have their own very intelligent managed connectivity platforms to allow automation, scalability, prevent unexpected costs, etc. So we like to work with those partners to try and deliver connectivity to a vast part of the market. And we also then work with very specific solution providers, the likes of Traffic Master, Masternaut, with vehicle telemetry solutions, BT Redcare for alarms and security, Ingenico and Verifone for electronic point of sale equipment for when we pay for petrol, the credit card, etc. And they take a very specific end-to-end solution to a very specific market, so they have that vertical play. As Telefónica, as I say, we believe power is in the partnership because we would have to be very siloed to say we're going to go after a particular market. And clearly, as a big organisation, we have to make very big bets. One of them's smart metering, so quite a big bid that we actually were, I believe, working with Arqiva to a certain extent, which is great. Connected home, smart cars, and there will be some big bets that we make as an organisation, but we operate a number of partner programs. We have a network here in the UK for the time being. We have a network in Spain, network in Germany, and world-leading coverage across Latin America as well as almost 400 networks across 197 countries with roaming agreements. So we can support our partners to do business internationally. I think the important thing that a telco can do, or at least a connectivity provider can do, is ensure that our connectivity is fit for purpose for the solutions that the IoT market requires, that customers require to solve their business solutions. So that can be very basic things like a SIM card, making sure it's durable, making sure that there's a SIM card available that can operate in extreme conditions, be that high temperatures, low temperatures, SIM cards that come on reels, ready to be soldered into units to go on vehicle telemetry solutions, etc. But also then truly smart connectivity. So lots of triggers and rules that can be built into your SIM base. What do you want a SIM to do if it does X, Y, and Z? If it uses too much data, too little data, tries to connect too often, doesn't connect often enough. But then also down to the connectivity itself. So now even here in the UK, we have SIM cards that will roam from network to network. So we know that network coverage is often a big thing that we talk about, each of the networks, and kind of who's got the biggest, who's got the fastest, who's got the best. And but I suppose the important thing is from a business critical solutions, which what we've been talking about today, and the chap from Cyberhawk earlier on, some of these solutions, if it doesn't work, someone dies. That's pretty critical, right? So making sure that device is always on. It could be an iPad in an ambulance. We have SIMs that will roam here in the UK. So if it can't get a signal on O2, it will automatically go to Vodafone, it'll go to E, it'll go to 3, it'll go into whichever network it can pick up. And that's all delivered at a fixed cost. So again, reducing unexpected costs. So interesting to sit on an industrial IoT panel where I'm not an industrial IoT expert, but because we play very horizontally across the market. So I had anything that was too technical, I'll be sloping them off one way or the other. So thank you. And hand over to Jonathan. Thank you.
Thanks, Bernie. Jonathan?
Thanks very much. Good morning, everybody. So I'm Jonathan Wiggin. I'm the Managing Director of EMEA for NWave. NWave is our core technology is a low-power, wide-area wireless networking technology to enable people to get small amounts of machine-generated data, whether that's from sensors or meters or other kinds of devices, over really long distances using very little power. So filling that connectivity gap left between, on one end, short-range devices using Wi-Fi or Bluetooth, which is great for some things, or on the other end, SIM, cellular-based devices that have long ranges but use shitloads of power. So we fill that gap in the middle, excuse my language. We are rolling out networks in various locations. We've got a network in London, we've got one in Cambridge, we've provided a citywide network for Milton Keynes with British Telecom as part of the MK Smart project. But we don't believe that it's good enough just to roll out networks speculatively and hope that people will come and use them. We believe that the value is in the applications. And so we like to provide networks to provide solutions to real problems. So with that in mind, there are 10 applications going out in Milton Keynes. In other places, we're connecting meters. In the US, we have projects where we're connecting agricultural sensors for smart and farming and precision agriculture. And we're also working with technology partners who are integrating our connectivity into their devices, whether it be waste management, geolocation capabilities, health devices, so event registers for the elderly and people in home care. And very importantly, we are opening up this technology because we firmly believe that proprietary communications technologies tend to not achieve widespread global adoption, and so we've supported the creation of a global open standard for low-power wide-area radio called Weightless N, which enables developers worldwide, royalty-free, to tap into the enormous store of innovation out there and create these transformative new business models and applications that can really make the industrial IoT, amongst other parts of the IoT, really bring the benefits that matter. You're going to have to listen to me again this afternoon if you're still here, so I won't talk for too long and pass it on to Paul.
Thanks, Jonathan.
Okay. Thanks, Jonathan. Hello, I'm Paul Green. My company you will not have heard of, I suspect, because we're a new startup. Been in existence for about 6 months now. But great news is that we've been so busy during that time, we haven't actually had time to produce our own website. So as a result of that, if you go and Google us right now, you'll be disappointed. So you're going to have to engage with some of the conversation later on today.
Although your Twitter tag Iotic Labs.
Yeah, keep going with the Twitter on that. That's great. Thank you. Just a quick question for all of you. How many of you are involved in anything to do with remote communication? Ooh, few of you. Yeah, quite a few of you, in fact. And how many of you are involved in industrial Internet of Things? Just 1 or 2 of you. Okay. And okay, so
I know.
So what's going on for the rest of you? Can you give us some ideas? Because quite a few of you didn't put your hands up at all. Is that just because you're just intrigued by this or just scared? Just a warm place to sit. Yeah.
So I was involved in an aerospace and defence project working with a Portuguese company called Prodia that developed diagnosis algorithms for structural health monitoring. So putting sensors on high-value industrial.
Okay, so lots of analysis and monitoring stuff. Have you got lots of people doing that? Yeah, you had a few people doing that. Okay, so there's a whole mixed bag of people here, which is intriguing because that's one of the things that I've noticed about in Internet of Things conferences that are worth going to at the moment, is that they've got a mixture of people that's doing lots of different things. And if you'd have been at the same conferences about 3 or 4 years ago, you'd have found a boring mix of telecoms companies talking to each other, pretending they knew the answers. And none of them are actually getting to what was really going on. And the reason for this is, I think, is that nothing's really new. And I sort of look along the panel here, and I just kind of noticed that almost everything we've been talking about has sort of got some history associated with it. And my history goes back to producing one of the very first synthesized single-chip radio and sticking it in a product. And that thing is now in the Science Museum in London. which is a bit scary because you suddenly realize that this technology stuff is moving along the pace. And actually, who's been doing remote communications to stuff? What's the oldest thing we can think of? Well, the oldest one I can think of is Henry VIII, who dug a lot of ditches all over the place, including here, actually, to drain areas that were flooded. And the way they controlled and managed that was they had wooden signals and guys sitting there all day long by little sort of sluice gate that they would pull the wooden board up and let some water out. Great, it worked. It was a system that just did the job. And what are we doing now? Well, we're doing the same stuff, but we call that Industrial Internet of Things, because essentially there isn't anything really new here. And that was one of the interesting challenges, because I was involved in building a business called Arqiva, which we've heard about just now, which actually links up with some of the other panelists, which is great, because we actually connect to the Azure platforms, which is fun. We're actively involved with our chums at Telefónica to do remote communications to stuff using mobile phone networks. And we also connect up with the weightless stuff as well, because we're involved in the weightless low power technology for communications. That's great. Does lots of stuff. We've got, I don't know, about 200 or more use cases I can think of, including lots of street lighting and control of vehicles and transport systems and pay-as-you-go insurance and stuff like that. But what's been interesting there is what's driving that market into kind of the industrial space. Well, it's fundamentally one horrible word the Americans have invented called servitization. It means to say you take a thing, and instead of selling a thing like a kind of boiler for heating up a building, you sell them heat, or you sell them light, or you sell them access times to roads, or you sell them, you know, hours of jet engine usage or something like that. That's the kind of stuff that's driving it. It's a change of business model. It's changing a product into a service. But what really became noticeable in that field was something really fundamental going on, is that no business is an island. All businesses work with other businesses to make their product or proposition work. They have to have relationship. None of us can exist without it. And we notice that this relationship thing is really well serviced by the internet. So wouldn't it be nice if the Internet of Stuff actually looked like the internet? Wouldn't it be nice if our core companies could talk to their subcontractors, suppliers, friends and relations, and do so easily? So as a result of Arqiva becoming a proper company, I've got bored, and I've now started another business that addresses the problem I've just talked about, which is making it so the Internet of Things actually starts to look like the internet. And as a result of that, what we're finding is people are changing their business model even further in the industrial Internet of Things to do some really exciting stuff that maybe we'll talk about today.
I think, thanks a lot, Paul and so on. I think I'll wind it back. I think the change that has happened, just taking an analogy to Henry VIII and building the channels and so on, is that you wouldn't see, you saw a boat once a week. You know, you saw it coming nice and, you know, sailing down and so on. The big thing about M2M and now IoT is the scale and speed. We talked about 50 billion devices, 30 billion devices. And it's that challenge now that's being put on this infrastructure that we all are building here. And that's probably one thing I'd like to ask the panel. You know, you just come and says, you mentioned, is IoT real? It's becoming real now. The volumes are there. Are we ready for these sort of numbers of the 50 billion? Or is that still further away in the future than we think? Or is it going to come quicker? Or is it going to come in the next 10, 15 years that we're actually going to reach that scale? Bernie?
I wish people would stop talking about 50 billion devices, because I firmly believe my sales target's based on that number. At O2, here in the UK, it took us probably the best part of 12 years to get our M2M SIM base to 1.5 million. It then took us about another 2 years to double it. So that is the speed at which this kind of took off. 27% year-on-year revenue growth last year. We've now got traditional telecoms companies wanting to get into this space, struggling somewhat because they don't know quite what to sell. They believe in the hype. They read all of the stats. They look at what all the analysts are saying, and they want a piece of that. They sign agreements with telcos like Telefónica to get their hands on the smart connectivity, and like, great, I've got this now. What do I sell? And it's understanding that value chain that we spoke about before in terms of who am I within that value chain? Where do I want to play? And ultimately, I think there's then the connectivity providers, the device manufacturers or distributors, there's the system integrators, all of these different players in the value chain, probably all trying to get to the same space, which is to be that integrated service provider, providing that true end-to-end solution for the customer. And one of the things we were just talking about very briefly outside of the panelists, and then it's a whole other debate, you probably have a whole day on this at some point, Simon, is when we get to that point, who owns the customer? And that probably would take about 8 hours to debate. But I'd like to start by saying me, I'll do it. But yeah, the growth's very real, as I say. 12 years to get 1.5 million SIMs, 2 years to get to 3 million. So that's the acceleration that we've seen, 27% year-on-year growth. So it is real.
Yeah. You're seeing it, aren't you?
Well, we were seeing a lot of growth. But I think the thing that we need to, that's catalyzing that growth more than anything, is that device developers are actually now starting to build devices that will communicate, right? So they're building low-cost, inexpensive devices. They're going to chirp small amounts of information, and companies are going to realize that they can put large volumes of relatively inexpensive devices out across infrastructure that they previously didn't think they could easily communicate to. So if we're going to do 50 billion, I don't know if it is 50 billion or it's 5 billion or whatever it might be, you know, companies and cities need to believe that actually, yes, it's worth me putting out 250,000 devices across my landscape. They will communicate, they will work, and I will get small amounts of information back that I can make use of. Now, for device companies to then start investing in building those devices and building that and innovating those things, right, so they can talk to each other, there needs to be networks available for them to talk across. And until, you know, the networks are there, the device companies are holding back and saying, you know, what should I be doing? Am I going to build on NWave's protocol? Am I going to build on LoRa? Am I going to build on Sigfox? Should I be building a 3G or an LTE Lite protocol? What should I be doing? So I think we're going to need some standardization around that, and there's going to need to be some confidence that if you're going to build device technologies so that we do get 50 billion of these things connecting, people know that when they build them and they start deploying them, that those will be there for the 5 years or 10 years that I'm building my new business model around. Because you're not going to build a new business model around something that in a couple of years' time is all different, and you've just invested substantially. I think the second issue that our companies are facing is, what do they do with all of this data that they get from all of these devices? I think the growth is there, by the way, and I think we will see over the next few years a very rapid uptake in the numbers of devices that we're going to see connecting onto the various networks that are available. You know, in the UK, around Europe, and in the US are going to be the leaders in that. I think the next big challenge is, you know, and I've heard this from a lot of my clients, are saying, okay, Sean, we get loads of data today. Okay, I don't just need more data. I don't know what to do with it. I don't know how, that's just making my business more complex. It's not simplifying it. So they need to figure out, I think companies need to figure out how they're going to use this information to transform their operations. And that means they need to change in the way that they look at their own business to use this information. So I think we've got a couple of challenges here, one of which is a technical challenge around standards and network availability that enables device manufacturers to innovate. And the second is companies realizing what they can do with this information. That's before you get onto the whole issue of cities, you know, wanting everybody to share everybody else's data in a whole open data platforms. And God knows, I'm not going to talk about that, right? So, come on, where do we want to go next?
Paul, I think, Paul, you wanted
Paul put his
to...
hand up, so sorry.
Sorry, Robert. You're next, Robert. Bob.
Thank you. Just a couple of comments around all this. Is
Quick
that
ones.
having been involved in this sort of end-to-end environment for a long time, it's very hard for us to stop thinking like that. Because, you know, the description here is you've got to have a device and you've got to have a blooming great silo to put the data in. And then when you've got it in a big silo, you've got to sort it out. Well, there's got to be something wrong with that. Because clearly it's not working. And actually, we don't live our lives like that. So all of us are generating vast amounts of data, and you've only got to look at the average teenager now and see the amount of data they're generating. And if that just went into a great big silo, we'd have a massive silo with lots of other teenagers trying to work out how to understand it and interpret it. No. Yeah. Well, the point is, though, is it just gets moved around a community and they do things with it. It might not be very much, but react to it and use it. So maybe we should start thinking about the models of behavior that we've got that actually emulate real life. And so that's the first thing, is to say, are we thinking about this the wrong way? And secondly, to say, when is a thing not a thing? Because people start talking about 50 billion things. What do we mean by a thing? Does this have to be a physical, electrically connected device? Or is it something that's identifiable, that has some information about it that we can relate to? Every one of us is wearing some clothes. And those clothes have been bought in some way or another, and they've got a barcode on them. Your credit card, or whatever you purchased it with, is associated with your clothing somewhere. That's a pile of information that currently exists. Is your shirt a device? So when is a thing not a thing in this Internet of Things? Because everything becomes relevant when you start thinking about it in a different way. And once you do that, you suddenly start realizing that the world is a lot bigger than you imagined, and that this Internet of Things is simply vast, and it isn't associated with devices, and it isn't limited to having new networks to support them.
Yeah. Bob, I think you're
Yeah, I'd take a slightly different view. I don't think scale is quite the issue. We're already storing, I think the current figure is 4 trillion objects in our Azure network. We have 4 billion emails a day, 2 billion minutes of Skype calling a day go through our network. And that's just Microsoft. If you then put Amazon, Google, the other large providers, you get a scale of the data that already exists and is networked. And I also think there are some really good examples of actually big data being analysed in a meaningful way. Gene sequencing is one. Actually, we're working with a number of World Health Organization to look at the way diseases spread. And you can actually make inferences now about enormous data sets. And you can make them because machine learning and inference analysis are developing in maturity very quickly. So I think when we think about where the future is, I think it actually comes back to a point that was made. What do people want? We sort of also find organizations who come to us and say, we've been told we need lots of information. So, well, fine, we can give you lots of information. What do you actually want it for? You know, what's the business imperative that's driving you to think that this information is going to give you something that will enable you to action on, to use a military term? And I think actually thinking about information not as just information, but as supporting business decisions, actually starts to put some relevance around why the Internet of Things is going to continue to grow. And I think it is about also the behavioral patterns of people, not just the data itself. So it's looking about the geo-mapping of where data is, the historical trends of where that data's come from, as well as the data itself. And actually, frankly, the technology is now getting to a level of maturity to enable that to happen. But we haven't got time to go into more detail, but I'm happy to talk offline.
Thank you. Jonathan, you've got a quick...
Very quick, yeah. So I mean, I think that one of the essential differences here is between M2M, which was siloed typically, where data was stored in-house using in-house enterprise systems. Often the difficulty has been like breaking that status quo. IoT is all about interconnectedness and a move towards open usage of data as well, which is going to require a lot of regulatory work. It varies from jurisdiction to jurisdiction. But the companies and the ecosystems that are forming around the Internet of Things, the industrial Internet of Things, they rather reflect the whole nature of this interconnectedness of devices. And these ecosystems are forming so that you can have, instead of siloed in-house systems, you can have analytics as a service. You have companies that drill down into the detail working on top of these platform plays or underneath them. And it's when you get this coming together that you release enormous amounts of value that might not have been envisaged before.
Well, thank you, Jonathan. I'd like to open up the opportunity for the questions from the floor to the panel. Since we've all the gentlemen here right now, experts in IoT, industrial IoT. Any questions? Question back there?
I have a question on data analysis and data sharing. It's a big business. It's gold dust. And I was wondering, maybe from an academic point of view, if you research, isn't one of the problems is that the cost of receiving that data is a lot. So do you think in the long term that data information will come down cheaper for academic institutes or for people who do research? Or a business model where one of the things you could do is sell the data to the government as well, you know?
I mean, I know from our personal experience that in a lot of smart cities initiatives, There have been companies, British Telecom as an example in Milton Keynes, who they built the data hub there, one of the main aims of which is to make data from a huge variety of different sources publicly available where possible. There are different levels of access, of course. Some data is anonymized, some data is more specific. But I think that there's a general move internationally to make more data available, especially to academic institutions, so that they don't have to pay for it. And also to really unleash the possibilities, as I think we all understand. There's huge amounts of data out there at the moment, and often when people are asked about what can we do with big data, people just answer by saying, well, we don't even know what we can do with it yet. It's going to kind of work itself out along the way. But in order for that to happen, you have to release that data to people so that they can get it working. So I think that cost model will go down and make it easier for people like you to have access to the data. You can have some of our data if you want.
Any other questions yet?
This is a question I'm going to ask every panel if I get a chance to. What is the key technical problems that you need solved in the next 18 months?
Anybody wants to have a go?
A very quick one. I actually think for the Internet of Things, I'm actually coming back to the last question for the availability of data to actually reach its potential. It's about open standards. It's about actually people being able to develop across the whole platform, from devices through network to back-end analytics, in a way that will interrelate and interoperability across the three. We have far too many standards in this area at the moment, and it's getting in the way. And I think actually it's relatively, I wouldn't say it's simple, but the concept at least is simple, and it would make a big difference.
So yeah, it's a very valid point, and we try and deal with this now. So we've got a protocol which can be ported to pretty much any silicon out there, whether it's Silicon Labs or Axem or Texas Instruments or whatever. So removing that obstacle to implementation, opening up technology, and also working with a sort of wide ecosystem of partners to create that interoperability to satisfy almost every client.
Paul?
I'm going to just dodge slightly your question by saying not a technical problem, but a regulatory one. Because there is a massive issue about what do we mean by my data. The example I gave earlier on of the fact that your barcode is recorded when you buy something and it's associated with your credit card means to say that it's already breaking the European regulations on data privacy. And that means to say that we're going to have enormous difficulty as we start to build out our networks and services, as we start taking data from one area to another. Because how do you know when a thing is owned by somebody or other, and when is that data private? That is quite a challenge, and something that we as a society are going to need to come to terms with. And you'll find that as you have an audience like this, I suspect that we've got an age spectrum here. I think it's fairly evident we have. And that I suspect that different parts of that spectrum will view privacy and security of data in completely different ways. And that's going to be an interesting challenge for us all.
Absolutely. One last question.
Yeah, also, but building on that, as a data subject, you have the right to a copy of information. So that earlier you mentioned, would you charge a university, or would you not? But technically, if we have a right to it, then if data belongs to all of us, then surely you can't charge for that. So what are your thoughts on that?
That's a good.
I think a lot of commercial businesses would have a different view on whether or not the data that they have and they believe they own around the business infrastructure that they're operating and the way they're serving the customers is in fact their data. And I do think there is a big commercial issue, as well as a regulatory one, as pointed out, around how we do share data and how we do receive the appropriate value for that information. Because at the end of the day, that's what causes businesses to be different from each other. They do have, an interest in the information they collect, how they serve their customers, how they differentiate their products, how they provide services, and they want to be better than anybody else in that and occupy a commercial space for that. and that information is quite important to them. So putting it out there on an open platform that everyone can get access to is going to be tricky for a lot of businesses to get a grip of. So I think we're going to have this issue of where does the boundary lie between information I can put out there, which is for the common good, and information actually which is highly proprietary to me as a business, and actually I need in order to defend my commercial position and make sure my shareholders continue to have a viable investment. So I think that's probably part of the challenge there. And I'm not a data guy, right? So I don't know the answer to that particular question. Maybe Microsoft does.
A very quick last comment, Paul.
Well, I'd make an observation that actually most of the data that's out there you've given away. Because if you're using any free service, the terms and conditions of that free service that you sign up to get it, basically you hand over the rights to that data full stop. I actually think, as a company, we think that that isn't transparent enough, but it's there. So actually, I think when it's data that you have given a considered right to, I would argue it's for the individuals to make an economic decision about giving that data, what utility do you get back. Unfortunately, that's very immature as it stands at the moment in the market.
Yeah, a good example of that is the fact that we all love Google Maps because it shows you.
Well, speak for yourself.
We all love Google and Microsoft and all these other great companies to provide all these wonderful services. Okay, and we're all prepared to use that service because it's a valuable. We like it, right? So there's a value quotient. We get something back for giving up the information, but actually giving up information about the fact you've got this type of car on your car park, or you've got this type of house, or this is what your garden looks like, and so on. It's quite sensitive information, and actually a lot of people might, if they would have thought about it for a few minutes, get quite concerned that this information is being captured and then just plastered all over the place. But in fact, we don't get too concerned about it because there's a value give, right? We get something back for it, and because we get something good back from it, we're prepared to give it up. And as long as that quotient is maintained, or that equation is maintained, then I think we'll be okay with this whole concept. So I do think businesses being able to provide people some good quality, valuable services in exchange for sharing information will be a business model that's going to evolve more and more rapidly. Anyway,
no, thank you very much. Probably on that note, I'd like to ask the audience to join me in saying thank you very much to the panel for their comments.